All right. Hello, geometry students, and welcome to 231, the triangle inequality. Something we're going to talk about to be able to check to see whether an answer is reasonable or not is kind of where we're headed. So if you take a look, notice we talks about how we now have several tools for describing triangles. We can talk about them with their lengths, like isosceles, equilateral, that kind of stuff. We can talk about triangles with areas now. We've talked about that, and angle measures, acute versus obtuse, things like that. But can any three line segments create a triangle, or are there some restrictions? And how can you know that the length you found for a side length is accurate? Okay, so what we're going to look at today in 299 is we're going to start talking about right triangles in particular, and then we'll get to more general. But if you take a look at this one, for example, first thing I want to be able to highlight is, let me go to Tools, and we'll grab the highlighter, maybe. Let's see here. And what I want you to take a look at is right here is the idea of the hypotenuse, okay? The hypotenuse of a right triangle is the longest side, which in the picture over here would be side AC. The other part is it's always opposite the right angle. Okay, so if you find the right angle of a right triangle, it is opposite of that. And the other part I want to clear up right away, a misconception, is the only type of triangle that has a hypotenuse is a right triangle. Okay. Otherwise, if you don't have a right triangle, then it's just called the longest side. It's not called the hypotenuse. So just a quick heads up on that one. So if you notice in this problem, let me go back to the pen here, it asks you to estimate the length of AC, okay? So what I would say is, if you notice, I would say it's definitely longer than 2, what we have over here. This side length is 7, so we know it's got to be bigger than 7, okay? So if we estimate the length, I would say it's probably somewhere, since this is 2 and that's 7, it's got to be bigger than 7 to be the longest side, but probably less than 9, so somewhere in that vicinity, the 7 plus 2. So my estimate is going to be somewhere in the 7 to 9 range is what I'm going to say is the length of that hypotenuse. So then in part B, they talk about a method that we're going to use that eventually we're going to talk about the Pythagorean theorem here in the next lesson, but this is going to lead us into that, okay? So what happens is we're going to go through and do 4 rotations of this triangle to create this picture right here. We are then going to find the area of the entire square. Then I'm going to subtract off the 4 triangles to have the inside square, and then from there I can find the actual length of the hypotenuse, which is also the side of the square. So it sounds complicated. It is kind of complicated, but we're going to get into it. So here's what I created for this one. So there's your triangle, and now let's say I do my first rotation here, okay, and I add that right there, okay. Then I go through and I take my second rotation, and we do it that way, and that one ends up going right here. And then finally I've got my third rotation down here. If I rotate that, I'm going to rotate it the other direction. And I slide that right in here. There's that picture that we were talking about right there. Okay? So if we take a look at that picture, let me fix this last one here just a little bit so it's a little nicer. If we now take a look at this, now I can go through and actually calculate what I have, because this is 2, that's 7, this is 2, that's 7, this is 2, that's 7. So this entire side length right here has a length of 9. So does that one. This is a square, a 9 by 9 square. So the total area that I have is 81. I'm going to put that off to the side. Okay, so that's the total area. Then if I'm going to find the area of these 4 triangles, okay, remember area of a triangle is base times height, but then we have to divide it by 2, or take half of it. So 2 times 7 gives me 14. Half of that means each one of these rectangles, or excuse me, each one of these triangles has an area of 7. I've got 4 of those triangles, so 7 times 4 gives me a total of 28. So if I subtract that, 81 minus the 28, the 4 triangles, gives me an area of 53. So this square right in here has 53 as an area. So the whole point of this problem, though, don't lose track of it, is I'm trying to find the length of the hypotenuse of that side, that triangle right there. That's what I'm looking for. Well, if you keep in mind about the area of a square, it is, these lengths are the same, all of them, okay? So a lot of times people would say, well, let's take the 53 and divide it by 4 then. But remember, 53 is not the perimeter, so I can't divide by 4. It's the area. How do I find area of a square? I take base times height, just like I do with a rectangle, except base and height are the same. So what I need to do is actually take the square root of 53 in order to work backwards to find the side length. So if I take the square root of 53, that gives me an answer of approximately 7.28 for that side length of my triangle, okay? And so if we take a look, that's what I ended up with. I found the hypotenuse. If I go back to this, I estimated it was between 7 and 9, and sure enough, this happens to be about 7.28 is the idea of what we have, okay? So there's that idea. That's a kind of a roundabout way of using areas to be able to find that length. Like I said, next lesson we're going to revisit the concept of Pythagorean theorem, and there'll be a lot easier way to find that. But for now, we're going to use that concept, okay? So there's that problem. There's that first idea. So now if we take a look in problem 2-100 here, notice it says for some different triangle where AB is 3 and BC is 4, Rory found that AC is 25. Donna's not sure if that's possible. What do you think? And so now here's the idea where we're headed. Is it possible to have a side lengths of 3, 4, and 25? And what I hope you visualize is I'm going to use the 3 and the 4. Let's say that that's my side length of 3 right there. Then let's say to it I add on just directly my side length of 4 right there. And therefore, if I were to go through and put my side length of 25 and try to create a triangle out of this, the 25 would be like that, okay? There is no way that I'm going to be able to put those 3 line segments together and come up with a triangle, okay? 25 is just way too big. It doesn't work today. So that's what we're going to look at now with something that's called the triangle inequality, okay? So if we take a look at problem 101, they talk about this shape factory and the idea of we come out with these 3 different side lengths. And what we're going to take a look at is if we were to find side lengths that had these final answers, which ones make sense and which ones don't make sense, similar to what we just did in problem 100, okay? And so in this scenario, I'm going to use, notice it says use a manipulative, or I'm going to use one of the e-tools to see if I have 3, 5, and 10 as my 3 side lengths, can I actually make a triangle out of that? So if we go to this, I'm going to go into the ebook, and what I am doing is I'm going to take a look here. This should bring up this possibility. And we said 3, 5, and 10 is what I'm looking for. So I'm going to change this to 3. I'm going to change that to 5, and I'm going to change that to 10. And what I need is for these point B's to be able to match up. So if I start moving this around, you can see, well, so far they're not real close. If I go through, let's say I put it there, let's see, I go through and I take care of this. No, that one doesn't work. What if I move it over this way? No, what if you notice, if I just lay it down so it's flat, it still doesn't work, okay? So in this case, if I go back to my lesson here for a second, maybe, there we go. What I'm going to go through and tell you is 3, 5, and 10, there is no way of making a triangle out of 3, 5, and 10. Okay, so that one's a no. The next we're going to try is 4, 9, and 12. Okay, so again, let's go back to our E tool. Let's change this into 4, 9, and 12. And let's try again. See if we can go through and put these together. And oh, look at this one. This one looks like we can maybe do it. And it looks like we're pretty close. my hope is that you can kind of see that without me playing around too much, that we can go through and actually get these to match up, okay, if I played around exactly. So if you notice, that one I can make a triangle out of. So let me go back to the lesson. This one is yes, I can make a triangle out of those three. For number 3, we've got 2, 4, and 5. Let's take a look at that one. We already have the 2 or the 4. Let's go to 2, and let's change that one to 5. And if I start moving this around, hopefully pretty quickly, you can see if I moved this, these would match up pretty quickly. Okay, so there's that one. Sure enough, that works. So let's go back to that and put that in there. This one is a yes. And finally, 3, 5, and 8 is our last one. So let's go 3, and we already have a 5, so let's change that to an 8 and see what happens. If I start moving this around, this one gets a little bit close. Let's see if I can put that there. We're getting close. Ultimately, though, what I want you to notice is if I put these end to end, this has a length of 8. And then if I put this other one, it does match up, but now I don't have a triangle because I don't have, it's not, there's no angles involved, okay? And so therefore, this one does not work with 3, 5, and 8. They do match up, but unfortunately there's no triangle that we can get out of that. So if we take a look, this one is also no, okay? So if you notice here in part B, now we want to kind of take a look back and say, all right, so for those ones that could not be built, what happened? Why did that not work? And why did the ones work for numbers like 2 and 3? Why did those make triangles, whereas numbers 1 and 4 did not? And my hope, if you think about this, or as we were working our way through this, my hope is that you came up with the idea that the 2 shortest side lengths must be larger, the sum of the 2 shortest. Let me put this one down. I'll actually write it down. Let's see. Do I want to put it in part B? Yeah, why not? What you should have come up with is the sum of the 2 shortest lengths must be, and I'm going to put this in here, greater than, there's our key part. It cannot be equal to, even on that last one, notice we said 3, 5, and 8. 3 plus 5 only equals 8. It's not greater than 8, so it does not work. It must be greater than the 3rd side length, or the 3rd length. Okay, that is what is called our triangle inequality. The sum of the 2 shortest sides has to be greater than the 3rd side. So if we go back up here and you take a look, that's why if you notice 3 plus 5, not bigger than 10, therefore we can't make a triangle out of it. 4 plus 9, those are the 2 shortest ones. They are bigger than 12, that's why it worked. Same thing with number 3, and same idea on number 4. Okay, so this should give you an idea where we're going to use the triangle inequality is if you come up with an answer, does it seem reasonable? Okay, so if I go back even to this problem now it should make a lot of sense as to why 3, 4, and 25 didn't work out. Okay, 3 plus 4 is only 7. That's not anywhere close to 25. So they made a mistake on there that we'll talk about again in the next lesson. So that should give you an idea. So then we come to, right here, like I said, notice they talk about the triangle inequality. Okay, that's what we just referred to. So if I'm going to try to determine the minimum and the maximum lengths, here's the idea. In part A, it looks like side DF is the longest side. Again, we've talked before, do not go over looks. Okay, do not go off of the looks. So let's assume, let's call that X. Let's assume that 13 and 19 are the 2 shortest sides. That means 13 plus 19 have to be greater than X. Okay? So in this scenario, if I add those 2 up, 13 plus 19 ends up giving me 32. So that means if I switch this inequality around, that tells me that X has to be less than 32. Otherwise, I will not have a triangle. So there's my maximum value. But what if, let's say the 19 was the longest side and these 2 are the shortest ones? then that means that x plus 13 has to be greater than 19 if those are your two shortest sides. Those two added up would then have to be bigger than that 19 if that's our longest. So if now I solve this inequality, I would subtract the 13 over, and I find out that x has to be greater than 6 in this case. So ultimately, there's my maximum and my minimum. This side length has to be bigger than 6 and less than 32 in order for you to have a triangle. So where that would come into play, let's say as we're moving forward, you actually find an answer for x, and we go through and we figure out how to find that. And let's say our answer is 2. This triangle inequality tells you right away it's outside the possibilities for x, and therefore you know you made a mistake. Okay? Let's do one more together. If you take a look at part B here, again, let's say I call that side x. If 14 and 15 are the two smallest sides, that means 14 plus 15 have to be greater than our third side, x. If I add those up, I get 29, which I'm now going to flip the inequality around. That means x has to be less than 29. That's our maximum value. If x is not our longest side, maybe 15 is the longest side, then our two shorter sides, x plus 14, have to be greater than our third side, which is 15. If I then subtract the 14 over, that means x has to be greater than 1. Okay? Now, so therefore, minimum value of x of 1, bigger than 1, I should say, and maximum value is 29. It's got to be less than 29. Keep in mind, by the way, bigger than 1 does not mean 2. It could be 1.1. That is bigger than 1. Okay? It could be 1.01. That's also bigger than 1. So keep in mind that we're not necessarily just talking about whole numbers on this case. We are talking about decimals, fractions, all that kind of stuff as well. So there's another way we can look at the triangle inequality. I know my answers for x have to be between 1 and 29. Okay? If we finish this out then, here's a math notes box just talking about the hypotenuse and the legs of a right triangle. This is setting up the idea of the Pythagorean theorem, so you can take a look at that. And then for today, there's your practice to learn, problems 2-104 to 2-108 in the practice to learn. Hopefully this lesson made some sense. Good luck with it. And if not, please bring those questions to class and we'll go over anything that did not make sense. Okay? Good luck. We will see you in class.